Okay, so we had started this one yesterday in class, and so we're just transforming um, a parabola, quadratic function right here, x squared. And so we basically are just taking these three key points right here, and then just using the transformations that we learned about yesterday. So I think we already did the first three together. So I'm just going to continue on down here. Okay, so looking at this one, I'm going to go ahead and put those three key points right there. So those three key points are for just x squared. So that would be for if I'm just looking at x squared, okay? So we're going to look at the transformations that are occurring here. So as you can see right here, we're going to subtract 1 from x. That's going to be our horizontal shifting. And so that's actually going to cause us to go to the right 1 unit, okay? And so then here when you add 2 to that, you're adding 2 to this result, so that's going to cause you to go up 2. And so that's the transformation that we're seeing here. So we're going to go ahead and go right 1, up 2, right 1, up 2, right 1, up 2. So we end up here, and then just kind of draw a bowl shape right here. You know, it doesn't have to be perfect, but you want to be in the right spot. Okay, so now this next one here, so we always start with the horizontal shifts first, by the way. So right here with this one, we're going to go to the right. We go to the right 1 again, okay? And then this 1/2 is actually, that's what you're multiplying the results by. And remember, the results are y. Like you plug in x and you get y in return, right? So the results are getting multiplied by half. So that's what you're going to do. You're going to multiply y by 1/2. Okay? So once again, I'll go ahead and put the initial points right here. There's the initial 3 points. And so we're going to go to the right 1, and then the y value, which is currently 1, gets multiplied by half, so it's going to actually go down to the 0.5 right here. Then at 0, 0, we go to the right 1, multiply y by 1/2. Well, y is already 0, so it just stays at 0. Then this point right here, we go to the right 1, multiply the y value by 1/2, so we get cut in half down to here. So what's going to happen is this causes the parabola to kind of open up a little bit wider. So it's just going to kind of open up at a little bit wider rate. So it's just opening up a little bit wider. And there you go. So you can notice the difference between the green one and this purple one. It just opens up a little bit wider, and that's what happens. And so if this would have been like, well, you'll see on number 65, you're going to multiply by 2. That's actually, well, -2. That's going to cause it to become actually skinnier. And so we'll look at that one now. So looking at 65 right here. So first you got to start with the horizontal shifting. So this time we're going to go to the left. So we're going to go to the left one. So it's the opposite of what you kind of initially think. Okay. So then here with the times -2, that's actually 2 transformations that are occurring right there. You're reflecting across the x-axis and y is doubling. Okay. So you can write it out as 2 transformations, or if you want to, you can just say multiply y by -2, and that actually takes care of the stretching and the reflection at the same time. So this will actually be 2 transformations right there for that. And then the last one right here, we're going to go add 1, so that's going to cause us to go up 1. And so this order is important, okay? If you go up 1 before multiplying by -2, that's going to cause some issues on your graph. Okay, so I'm going to scroll up a little bit so this isn't completely covering this up. This might be a little challenging to do. Okay, so let's see. So my initial points are right here, okay? And basically that's kind of known as your pre-image, okay? And then the transformation is going to cause me to go left 1. Then I multiply the y value by -2. So my y value is currently a 1. But when I multiply by -2, it turns into -2 down here. So see, it was 2 transformations. It stretched up to a 2, and then it also reflected down over here to -2, okay? And then I go up 1 as my last transformation. So that's where that first point went. So left 1, and then when you multiply by -2, 1 times -2 puts me down here, but then that up 1 caused me to end up right here at -2, -1, that point right there. Okay, the next point, we go left 1, then I multiply by my y value by -2, but that actually doesn't do anything because y is 0. So 0 times -2, that doesn't change anything. And then I go up 1. So this is kind of interesting. I actually land on that original point from the other one right there. Okay. And then my last one here, let's see. So I'm going to go left 1, multiply by -2. So 1 times -2 is -2. So all of a sudden I reflect and stretch a little bit, right? And then I go up 1, so I end up right here. So this parabola is going to open downwards, and it's a little bit, you'll notice it's a little bit skinnier, it's a little bit tighter right there, because of that multiplying by 2. It causes it to kind of keeps the sides a little bit closer. But anyways, okay, so that is going to be for parabolas, and so we got 4 more to look at, 4 different types. But the good news is they're all going to be kind of similar to what we've seen here. What we'll do is it'll start out pretty simple. We'll start out with like 1 transformation, then we'll go on to 2 transformations, and so on as we introduce each type. Okay, so that's our parabolas, quadratics. Now we're going to look at the square root function. Okay, so the square root function is the square root of x is the most basic one, and so the transformations will be applied to that. Okay. So note when you have square roots, you can only evaluate non-negative numbers in order to return a real number. So you don't want to square root anything that's negative, okay? Because we won't be able to graph it. Also, you typically want to evaluate square roots of perfect squares. So for example, I'll make a table and we'll just use a couple of these, okay? So using my square root function right here, so if I let x equal 0, well, the square root of 0 is just 0, okay? Let's see, if I plug in a 1, the square root of 1 is just 1. Now, I probably don't want to do 2 or 3 because the square root of those are going to be irrational, they're going to be decimals. But if I, oops, erase that. If I want to go ahead and maybe go to 4 next, 4 would probably be the next best one. So then the square root of 4 is 2. Then after 4, it jumps all the way to 9. So then the square root of 9 is 3. And that's going to be off my graph, so we probably won't use that one. But what we will use are these first 3 points right here. So we're going to use 0, 0, 1, 1, and then 4, 2. So those will be our initial points. And then we'll just apply our transformation to those 3 points right there. Okay? All right. And the best way to describe this is it's like half of a parabola on its side. So that's kind of the shape of this right here. Okay. So coming down here, so I'm going to go ahead and put those initial points, 0, 0, 1, 1, and then 4, 2. And so that would be the original right there, but we're going to transform this. It looks like we're going to go up 2. So we'll go ahead and go up 2 units, all this right here. So up 2, up 2, up 2. And so there we go. There's my transformation right there. So just try to make the shape, like I said, like half of a parabola on its side, and you should be fine. Okay, so then the next one, you have plus 2 again, but this time it's directly associated with the x prior to the radical being applied. So that's going to cause your horizontal shifts. And so since it's plus, it's going to be the opposite of what you think. We're actually going to go left 2. So once again, let's see, I'll put those original points. And then we're just going to translate it to the left 2, to the left 2, and then to the left 2. And then we just kind of go up like that. And there you go. That's it. Okay, so now we're going to throw in 2 transformations. So the first one's going to be, let's see, we're going to go left 1. And then you have the negative that's getting multiplied, like basically negative 1's getting multiplied to your result. So that's going to cause you to reflect across the x-axis, or you could say multiply y by -1. It accomplishes the same goal. So let's see, reflect across the x-axis. Okay. But if you wanted to, you could just say multiply y by -1. That's basically what's occurring. All right, so we go ahead and plot these points. Okay. And so we're going to go left 1. And then if I reflect across the x-axis, I'm actually on the x-axis, so that actually just stays right there. Left 1, and then if I reflect across, I go down to y being -1. Left 1, and then I reflect down to y being at -2. And then, let's see, we'll go ahead and draw this. There you go. All right. Okay, so I got a couple more down here. Okay, so 73 is a little tricky, and that's because you got that negative directly with x. Okay, so we're going to have to deal with that. But the key on this one is actually you have to take care of remember, horizontal transformations are first. So this is important. The order definitely matters on this one here. So that that +2 is actually going to cause us to go to the left. It's going to cause us to go to the left 2, okay? And then that -x, you're multiplying x by -1. And I mean, that's basically what, you could write that down if you wanted to, multiply x by -1. Or basically you can just say reflect across the y-axis. So whatever, you know, in the past, I've kind of worded it both ways. Sometimes I just say multiply x by -1, but however it makes sense to you is fine. They both will achieve the same goal. So let's see, we'll start with these points. Oops. Sorry, my gizmo's kind of not working properly. Let's see. All right, sorry about that. So let's see, we got our points right here. And so what we'll do is, let's see, so we want to go left 2, but then I reflect across the y-axis, or basically multiply x by -1, so I actually end up right here. That's kind of interesting, okay? Then here I'm going to go left 1, 2, okay? Then I reflect across. That's kind of interesting. I actually end up right back where I started. So the two transformations actually made me go right back to where I was. And then this last one right here, so we're going to go left 2. Then I reflect across. I'm going to end up right there. And so now we'll go ahead and draw this. And so what's interesting is when you have that reflection across the y-axis, this is going to cause me to go the other direction. There we go. So that's that one. Okay, so then 76, let's see, we'll start with this right here, which is going to cause me to go left 1. All right, and then here, now you're multiplying your results by 2, and by results, I'm talking about y, so that's what we'll do. We'll multiply y by 2. Okay, so we'll go ahead and put those first few points here. So we're going to go left 1, and then multiply y by 2. Well, y is 0, so that just stays right there. Let's see, we're going to go left 1, and then multiply by 2, so 1 times 2 is 2, so it comes up here. Go left 1, multiply by 2, so I'm going to show up all the way up here at 4. And so now we'll go ahead and connect the dots, and so kind of like with the parabola, when sometimes it opens up wider, it opened up wider in this case. So it just kind of opens up at a wider pace right there. Okay, last one. This one actually really is not bad at all. So right here, that +2 is going to cause us to go left 2, okay? And then this -2 is going to cause us to go down 2. And so we're going to take those 3 points to start with and then just translate them. Okay, so let's see, left 2, down 2. So left 2, down 2, left 2, down 2, and then left 2, down 2. And so now we'll go ahead and connect the dots, and there you go. Okay. All right, so that's two of them. That's the parabola, and this is the square root function. So what I'll probably do is go ahead and stop here and then make a video for the other ones.